Okay. So hi there. Yeah, I just will give you a short quickie about my experiences with JavaFX running on the Raspberry Pi in combination with Nashorn. So first of all, who knows what Nashorn is? A few? Okay. Who tried it already? Oh, just a few. Okay. So we just have 15 minutes, so I will skip a lot of the details just to get you an idea what it is all about. So first of all, my name is Gerrit Grunwald. I'm working for Canoo Engineering in Switzerland, JUG leader and other things, mainly working on JavaFX and embedded devices. So this session will be about Java and about scripting. And therefore we use JavaScript, right? So that's the idea. And this is nothing new. You might heard about Rhino, which is there for, I don't know, many years. It was part of JDK 6. And it turns out that that Oracle created a new JavaScript implementation named Nashorn. So that means we have JDK 8, and with JDK 8 we get, of course, JavaFX since JDK 7. And now we also get Nashorn. And so what does it mean, right? So what can you do with that stuff? So first of all, it's a JavaScript engine implemented in Java, and it's part of the JDK. And of course, you can now argue, well, you know, there's JRuby. You can also use stuff like Groovy or Python or other scripting languages to script your Java code. But you know what? I'm some kind of lazy. And because Nashorn is just part of the JDK, why fiddling around with another additional jar that you can have to keep track on and all that? So I decided, let's give it a try and see what you can do with Nashorn in combination with JavaFX. Well, I told you already that I'm mainly into embedded and JavaFX. And if you think about embedded, then it's stuff like on a train station, you have the timetable of the upcoming and outgoing trains, for example. This is a typical example where you can use an embedded device in combination with JavaFX and to display something. Well, the problem with these things is you place them on the train station, and then there is most of the times not a direct connection anymore to that device. That means you set it up once, start it, and then keep it running. And if you have to remote configure it, sometimes you might have seen that you got this nice Windows blue screen of death, and it reboots. So that means most of the times today it's just Java. It's not Java, it's Windows systems running whatever software, I have no idea. But it's for me it's an overkill, right? So you can better use an embedded device to do that. Well, you can also think about monitoring apps or home automation, displays, so everything that is related to visualization of data and running on an embedded device. So why is this interesting in combination with Nashorn? Well, the interesting part is, who has a Raspberry Pi? Well, that's a lot. Who uses the Raspberry Pi really? Not just lying on the desk, okay? And who uses Java on the Pi? Well, that's good, a few. Then you might have figured out that it's some kind of boring if you create something, run it on the Pi. That means you create a jar on the desktop, coding, compiling, SSH, copy the stuff over, start it, test, okay. Not perfect, we have to change it. Back to the IDE, make some modifications, compile, SSH, copy, start, and so on. So the feedback cycle is quite long. And this would, for me, that was the reason why I would like to start using some kind of a scripting capability to be able to just create the jar once, SSH directly to the Pi, and modify, for example, a configuration file, something like that. So I just would like to get rid of the compile stuff on my desktop PC. And therefore, I figured out we have 3 points that make sense if you have some kind of a visualization running on a Pi, which is, first of all, you can do something with initialization using JavaScript in this case, or configuration. The differences I will explain. Or you can do also remote configuration, and therefore I used a little bit different approach. Well, the example should be, yeah, I mentioned it already, using Java, JDK8 with JavaFX, with Nashorn on a Raspberry Pi. And it should be a temperature monitoring application. Very high-tech and absolutely perfect example to do that. So very simple. Well, the requirements should be create an application that shows temperature. Unit should be degrees Celsius, 2 decimals, and the info text in the display should be metric, because we use metric system, okay? Very simple. So this is our standard LCD control, JavaFX control, and now it's just plain, nothing in there. So we have to initialize it first, and therefore we use some code. So I created a builder for that, like we saw it in JavaFX 2, and where I just define size and which is visible, title and decimals and all that stuff. Well, that's typical stuff, you know, right? Then I created a method to set the default values. This is now this is German, means Temperatur, it's temperature, and degrees Celsius, the minimum value, the maximum value, and then I set the info text to metric like in the requirements. So that's the result. Fine. Everything is coded, configuration, everybody's happy. Okay. So now we have the idea, well, that's good for Germany, but what about the US? Well, we have new requirements then, which means we have to support Fahrenheit. Okay, so that's easy. What to do? We just have to add, or we have to use Fahrenheit as the unit. We take, for example, 1 decimal. The info text should now be Imperial, because we use Imperial System, and then maybe change the style, because that was not the nice one. We need a different one, so the style should be green. Okay. We go to our default method, and then instead of setting it to temperature, we set it to temperature, unit to Fahrenheit. We adjust the minimum and maximum values, and adjust the info text, and also set a different style class, which is the way you do it in JavaFX. Well, okay, that works. Means going back to the IDE, code everything, and then recompile it, deploy it to the Pi, and you are in this cycle now, which is modify, compile, deploy, verify, modify, and so on, right? So this is a really time-consuming process. I mentioned that in the beginning, and I hate it. If you work with this embedded things, it really takes time to do that, and it's always compile it on the desktop, try it on the desktop, it works, move it to the Pi, start it, okay, it's fine or not, then you have to do it again and again and again. Well, and this is possible if you have the Pi in direct access, but what will you do if if SSH is not available, for example, right? We will come to that later. So that means the idea is, in this case, just use scripting. Instead of coding all this stuff, use a script. Now you can argue that you can also use property files, right? It's a valid solution. Create a properties file. In the properties file, you define, for example, unit, string, decimals, and so on. The drawback is you have to create this for each of your control properties, and you have to code it, right? You have to read the properties file, and you have to react on every single line in the properties file, if you like it or not. And if you have to add another property from your control, you have to, again, edit the code, add something to the properties file, and so on and so on. So the advantage of using scripting is that you get a direct handle to the control in the script, right? So that means instead of load the configuration, check everything, set the control, I just now take the control, the handle of the control, the object, and pass it to the JavaScript, modify it in the script, and so I can, I just have to reconfigure the JavaScript file on my Pi instead of recompiling the application. So that means the procedure would be load the JavaScript file in the initialization phase, get the script engine, and then invoke the JavaScript method on my LCD object. Well, in code that would look like this. This is the JavaScript that I need to modify the LCD display in the way that it shows temperature, Fahrenheit. So in principle, this is the same that we saw in the Java method, but now it's JavaScript. And to be able to do that, you have to import the LCD control from the packages there. It's this packages, EU, Han Solo, and so LCD control. And then you create a JavaScript object. And for that object, you create this method that I called here init LCD. And you pass the LCD control to that method. Right? So that's the idea. And if I load this file during startup, then it will, and give the handle, the object, the LCD object to that file, I have the possibility to directly modify my control, which is much nicer than creating a properties file, for example. Well, then, of course, I have to load the script. And the nice thing is, if you evaluate a script with a JavaScript engine or with a scripting engine in Java, it's just evaluating a string, right? So in the end, you just have to read a text file, get it as a string, pass it to the scripting engine, and then evaluate it. That's the idea. So I just have a method that loads the script, give me back the script content as a string, and then I have a method that initializes the LCD. And you need some fallback mechanism that if the script is not valid or if it's empty, then it will just call the set LCD defaults method that we saw before. So that means that it doesn't crash. But in principle, if it's valid, it will just evaluate the script code and execute it. It will be interpreted by the Nashorn JavaScript engine. Well, and the result is then this. So that means now we have the possibility to create a scripted configuration, or initialization in this case, I have to say. Well, that's nice, but this is only one time, right? I start the application, it loads the script, done. What about changing configuration during runtime? So that means, think about this timetable display at the train station. It's standing there. You now would like to reconfigure something, change colors or whatever it is. And how can you do that? Well, the idea was you create just an empty JavaScript file and attach a FileWatcher, which is part of JDK 7. It comes with JDK 7, as far as I remember. And that means you have something like a file system listener. So if I add this listener to my JavaScript file, I can, during runtime, I can just edit this file. And as soon as I save it, I get the event that the content of the script file changes, and then it will be executed and interpreted by the JavaScript engine. So that means I have something like a live update of my application. In this case, it's just a simple LCD, but you can think about everything. Well, that's nice, but you need SSH, right? Otherwise, on the Pi, no chance. Well, and then it would look like this. I just have a method that creates this FileWatcher, and the interesting part is this one, where I say set on file modified, and then just I have to use the platform run later, apply configuration script. And in this method, I just execute the script in the same way we saw it before. I load the string and evaluate it by the script engine. Well, then it's hard to read maybe, but this is just on the shell. I go to Nano, for example, and edit the file on the Pi. Then this is again the same, it's just a JavaScript file, right? It's nothing special. And in this method, I call it here config LCD. I just change the value and then the text on the lower right side to SSH and the style class to a different color. And then it will look like this, right? So I can do it via SSH. Well, that's great. But like I said, what happens if I don't have the ability of SSH? Well, and in my case, this is very often the case. So the Pis are hanging around in my house somewhere. So I don't have a network connection to every Pi, and so I can't really SSH to everyone. So if I have no SSH, the idea is make use of XMPP. Who knows what XMPP is? Java, the chat protocol, right? There's a nice implementation of Ignite Realtime for Java. And I used this so-called SMAC library and implemented it in my JavaFX code on the Pi. That means I have something like a remote configuration now that I can also handle from my mobile phone or from my iPad or Android device or whatever. So the idea is I implement XMPP in my application. Then I can prepare different JavaScript files on my site wherever I am. and then just pass the script text as a chat message to the Pi. And because it's a string, I can directly pass it to the JavaScript engine, and it will be executed. So it would look like this. This is a chat client on the Mac. So I just, in the first line, I state something like script colon, so that the Java code that gets the message knows, okay, now the rest is a script, and then it takes just this text and applies it directly to the control. And in this case, it should show XMPP on the lower right corner, change back to Celsius, and change the color one more time, right? So the result will be this. And unfortunately, I didn't brought my Pi with me because it's not enough time in 15 minutes to set it up. So if you would like to have the source code of that project, you can either make an image now or take a look at the slides after all. And now we have 3 minutes left, so I will show you that it worked because I set it up on my machine. So that means we have, for example, this. Let's have a look. Okay, here we go. This is the LCD display, and that is the same on the Pi, right? For those of you who have never used Java on a Pi, it's the same. You can use the same code on the desktop and then just take the jar and run it on the Pi. It's no problem. So that means, you see, I have the already initialized version, and in the output downwards you see script LCD init.js loaded. So that means this one was loaded and it was applied. So now if I take a look at the config script file, it's this one, right? So this is just the text file, and I have the filesystemwatcher on that. And I change now the whatever to 20 and set the LCD title, set it to Devox. So if I save that file and take a look at the output, and now you see that takes some time because the file system, here it goes. So the file system watcher, it has a cycle like polling the files, and the next time it polls the file, it will just take the script code and apply it to the application. And in the last minute we have, I just show you the XMPpre approach. You see, I just take a chat client, and here I have the text. It's the same as before. Just copy that and send it to the Pi. Now we have to open that one and execute it. And you see, it directly gets the message, and that can be done from everywhere. I can use my mobile phone to do that. And so you can really make use of scripting using the Raspberry Pi, for example, but this would also work on any desktop machine or desktop application, and it doesn't have to be JavaFX. It could also be Swing or whatever, but scripting with Nashorn is really nice. So if you didn't try it yet, feel free to try. It's really a really nice implementation on JDK 8. So it says 0 minutes left. If you have any questions, just grab me, because I think we have to stop now, right? So thanks for listening.